So we kind of ran out of time for 11 in class today, but those of you stay behind, you will see that the calculation for 11 is as follows. When they give you Ka, you should be able to write the Ka for the acid dissociation. So acid, and then this is the H plus and the conjugate base. Okay, Ka value is here. And then these two are X and X because they're going to dissociate into two places, X and X. This here is, in this case, acid concentration is 0.1 molar, right? Notice that usually you do 0.1 molar minus X, but we're ignoring that X because it's a small number approximation. So next what you do is this time that 0.01 is basically 10 to the negative 2. So we're going to get 4 times 10 to the negative 6. To get rid of square, you do square root. Square root of 4 is 2. Square root of 10 to the negative 6 is 10 to the negative 3. Okay, which is the X plus concentration. So from there, we're going to do negative logs of H plus concentration. We know that 10 to the negative 3 will give us 3, but you're going to say negative log of 2 is going to give you about negative, less than 1-ish. It's probably going to be about 0.5-ish in that region. But either way, you're going to say 3 minus some number, so it's going to less than 3, right? But it's going to be, So X is gonna be greater than 2, but then less than 3. Okay, so or the pH, I should say in this case, not H, pH. Okay, so that's gonna be in the range, and that's why correct answer for 11 is B. All right, let's take a look at 12. Okay, in 12s, we're looking at here 200 milliliter of this molarity solution is added to this. Okay, another one, again, I won't ask you this question. I would make it side mark for this is for the chapter 17 question. Get mixed in there. But it's basically titration. If you wanted to know, I can actually write out for you what it's actually going to look like. You're going to have NaOH plus HCl. So what you're going to have is you're going to get NaCl and then plus H2O. Okay, so you have to see who is more. The one that have more stuff is going to be the one that is going to make that pH, okay, influence that pH. So let's take a look. So you have concentration and the volume. So if you multiply these two, you're going to have more. Right? You have to change into liter, of course. So that means you're going to say that is 3 times 0.2, right? The liter, milliliter, liter, right? So that is what molarity, right? Mole over liter times liter give you mole. Okay, in this case, that would be 0.6. That's gonna be NaOH. So NaOH is 0.6. Now we're gonna do this guy. This guy is 1 times 0.7, so that means 0.7 HCl. Guess what? Who is mole? HCl is mole. So we're gonna have leftover 0.1 HCl. Left over. So this is gonna be 0 when it's finished, right? This is gonna be 0.1. So what happened is this is a strong acid. So that means that my concentration of H plus is 0.1. Okay, 0.1 is the same thing as 10 to the negative 1. 10 to the negative 1 pH is gonna be 1, right? Because pH is equal to negative log of H plus negative log of 10 to the negative 1 is 1. Okay, so that's what it's gonna be. That's 12 is A. All right, let's look at 13. Okay, 13 you have solution 1, 2. Okay, acid, and then we have a Ka. Okay, let's see. Based on the Ka, look like this is a little bit stronger. Okay, so we know we kind of know that this is a little bit stronger. Okay, let's take a look at the answer choices. What they're saying, they want to know the pH of this, and then we're going to talk about acid base. Easy. Let's first figure out which one is acid, which one is a base. Okay, the one with the H's, these are acid. The one with these minuses are base. Okay, so we know that, and then now we're going to see. So you're mixing. And since they have the same concentration, right? If the concentration different, you can just use Ka. Because they have the same concentration, you're going to use a Ka. Because this Ka is bigger, this dissociates more, right? Ka bigger mean dissociate more. Okay, in this case, it's a stronger acid. Okay, so based off of this, we know that CF3CO2H is going to be stronger acid. Okay, yeah, so that means if you're gonna look in that pair, if this is a stronger acid, what can I say about the base sites when you compare the other two? Because remember, Ka and Kb value is 10 to the negative 14 divided by Ka will give you Kb. So what can I say about these two Kb? Well, since this Ka is more, this Kb is gonna be less, right? Kb2 is gonna be less than Kb1 in here, which means that this is gonna be stronger here. This is a stronger one here, okay? Kind of. Or actually, yeah. Okay. I mean the solution one. Okay. So let's see. So in a solution one, solution one is weaker, solution two is stronger. So solution two is a stronger acid, so this pH is lower, so pH is less than solution one. Okay. Make sense what we're saying in here? So that means solution one has to be higher pH. Okay, so we're gonna stop picking here because they all only talk about solution one, not solution two first, right? So solution one is higher pH than solution two, right? So that means C and D are wrong. Okay, now I have A and B. Now, why would solution one have a higher pH than solution two? Well, solution one is higher pH because this is a stronger acid. No, if it have higher pH, that means it should be looking for base. So higher pH, stronger base, and yes, we know this is a stronger base. Okay. All right. Number 14. Okay, water. We talked about this question in class before. This is a dissociation of water we talk about. Okay, take a look at Kw. What happening to the Kw here as this go by? Okay, pKa is decreasing, right? Temperature is increasing. Your pKw is decreasing. Remember, pKw and Kw are backwards, so Kw is increasing. So far, so good. Okay, Kw is related to concentration of H plus and a concentration of OH minus because they multiply together to make Kw. If this is increasing, these two are also going up. So if this is increasing, so what's going to happen about pH? This concentration increasing, when you calculate pH, pH is decreasing. Okay, so that's what we're doing. So the correct answer is D. Temperature increase, pH is decreasing. Okay, it cannot be exothermic. In fact, it is endothermic because as temperature increases, right here, the temperature is increasing here. What happening to the Kw? Kw is increasing. Okay, that's not favoring this side. It's favoring is right. So that means it's not exothermic. The exothermic will have been go the other way. This is an endothermic reaction. Okay. If you have a question about exo-endo with a temperature and a K value, look at chapter 15. Okay, chapter 15 we talk about exo-endo and how Lachalier shift and talk about K value. Okay. 15. Okay, 15 is a long question looking, but we should be able to figure out. Okay, first off, they are all acetic acid with a various concentration. Okay. We can kind of calculate what happening to the acid when we are diluting. Okay, so you can see that concentration diluting here, and then you have pH and a percent equation here. Okay, let's take a look. What happened if I'm gonna dilute it? What happened to a pH? Okay, remember acid. If you're getting diluted, okay, same thing with base. Same thing with strong acid. You're getting diluted. This is diluting. You're adding water. Okay. If you are diluting it, your pH should be becoming closer to 7 for the acid. Okay. If you dilute the base, it's gonna be closer to 7 also, but on the other way. Okay. So diluting the acid, we're gonna getting bigger and bigger, closer to 7. If you're diluting the base, it's gonna be smaller and smaller, closer to 7. Okay. So in this case, I'm gonna go ahead and look for that explanation. So A is wrong, okay, B is also wrong, okay, I'm gonna have C and D. Okay, C and D is correct on this part. Now we need to think about percent ionization. Okay, What happened when the pH is increasing? Okay, let's talk about it. pH increase, concentration of H plus is what happening? It's gonna be decreasing. If the concentration decreasing, percent ionization, are we having more iron or less iron? It's gonna be less. It's gonna be decreasing. Okay. Wait. Sorry. No. Wait. Theoretically speaking, is less number. Sorry, not this way. pH is increasing, right? So pH is increasing, going that way. Okay, let's talk about what happened with the ionization. Ionization, how do we calculate it? Well, ionization is concentration of H plus divided by concentration of HA, right? Okay, in this case, yes, H plus is decreasing, but how about your concentration HA? It's also decreasing. Okay, you're dividing these two numbers, basically. Okay, so if you're dividing by smaller number, it's gonna get bigger. If you have a smaller number on the top, it's gonna be smaller. So this way doesn't make sense this much. So that's why you can't say that H plus decrease, ionization decrease. It's not that case. It's actually increasing. You have to remember this. Dilution make more ions. Okay, let me explain why. Let me write it down what does this look like. Acetic acid, CH3COOH. Okay, diluting, you're adding, the reaction gonna look like this. H plus is gonna go H plus and then CH3COO. Right, now it's not really H plus, it's actually H3O plus. Okay, so what's happening here? Well, take a look. If I add more water, according to Le Chatelier principle, what's going to happen? It's going to go that way. Okay, more water, meaning it's going to go that way. I'm going to have more H plus iron. I'm going to go this way, right? I'm going to have these. Now, notice that you might say, well, Michelle, you have more H plus, so why pH is going down? It's not why pH is going down with more H plus. I know it seems to be contradicting. It's more H plus, but remember, it's a concentration. So because you also has more water, more volume, right? So just increasing more is not enough because molarity is equal to mole over liter. Imagine you are increasing this a little bit, but you're increasing this a lot, right? Then this is gonna get smaller. I like to think about example like, let's say buying something, right? You can say like the top is like maybe how much money you get and the bottom is how much money is cost, right? So you're saving up or something and what you cost, right? So let's say you get a raise. You get extra money, your allowance, right? Your parent give you more money that week. Right, you get 5 more extra money. So you're like, okay, yes, I'm gonna able to buy the toy. Well, but bad news, economy happened, price change. Your price of the item that you want to buy used to be, let's say $10, and you're like, oh, I only need $5 more. I'm gonna get it there. Right now, your things all of a sudden double. You used to get $5, and your parent give you $5. So you're like, okay, all right. But your price is also increasing. Your price is instead of costing $10, now let's say cost $100. Well, now you're in trouble, right? You're getting so see that like how the one increase doesn't make this whole thing like matching. It's also have that bottom part. I know it's confusing. You can try plugging in with a number, but either way, here's what you need to know. Okay, I'm gonna write down the note on the side for you for this one. Acid. Okay, when you dilute, meaning you are adding water, it's gonna happen, right? It's gonna happen these. It's gonna happen these things, okay? These two things. What's gonna happen? Your pH would increase, right? Closer to 7 as it increases. It will not pass 7 because you're talking about acid, okay? And because you're diluting, your percent ionization will go up, increase. Okay? That's all you need to know. All right. Sorry, I just kind of make it long, but I want you guys to know rather than memorizing it. Let's look at 16, the last multiple choice question. Okay, the Lewis dot diagram is given here. Okay, you already know. I did this in class before. You have HClO3 versus HClO2. Which one is a better acid? It's this one. This one is a better acid. Remember this O. This O is going to distribute the electron and it's going to be able to hold on the electron. Your conjugate base of this acid is better at holding on to that extra electron after the proton leave than this guy because they have resonance structure. The oxygen may more disturbed, more distributed, right? So that's what we're saying. So let's take a look. So based on that, we already know that this is a stronger. So let's find out. Okay, that's a stronger, that's a stronger. Okay, these two are out. Okay, based on this, okay, it's not London dispersion force. This is a polar molecule, so that's off. So because additional electronegative oxygen atom on the chlorine stabilized conjugate base. That's all we want to say. This is the answer. Okay, also make sure you know this reading, the reasoning. This one is really good reasoning or writing. If they ask why this one is better acid than this, you're gonna explain in terms of this. Make sense? Okay, that's all for today. Go make sure you study. Okay. I hope you guys take a picture of this today, or at least know this. I would be asking you guys small question, not a lot, about these material tomorrow. Okay. So tomorrow we need you to understand all this. Okay. You need to make sure that you got this because that's what we're gonna be quizzing you. Okay. That's it. If you have a question, send me down, remind, or make sure you ask me tomorrow as soon as second period started.